Hi, my name is Emily Love, and I will be guiding you through a bioenergy site assessment that I have prepared for ET 255. I will now begin to give you an introduction and a little bit of background information about this project. The objective for this assessment is to examine 4 sites: GW Hill Demonstration Forest, Hoseley Forest, Schenck Forest, and the Lake Wheeler Field Laboratory for their potential to produce biomass-based energy which caters to NCSU's energy needs within the limits of sustainability. As you can see here, we have a table containing information on NCSU's annual energy consumption. I chose to focus this assessment on the consumption of electricity measured in kilowatt hours rather than BTUs for the sake of simplicity. In 2014, NCSU consumed 208,327,176 kilowatt hours worth of electricity, which cost the university a whopping $16,112,209. Since we spend more money on electricity than any other source, it is important that we begin to supplement our energy needs with renewable bioenergy. To begin, GW Hill Forest is in Durham, North Carolina, which is approximately 30 minutes away from NCSU's campus. It is a total of 2,450 acres. It is currently used for a summer camp coordinated by NCSU's College of Natural Resources. NCSU would like to maintain a portion of this forest for educational purposes. Next, we have Hoseley Forest, which is in Franklin County, North Carolina. It is approximately 1 hour away from NCSU's campus. It is a total of 252 acres, and it is currently managed for pine and natural bottomland hardwoods. Next, we have Schenck Forest, which is conveniently located approximately 10 minutes away from NCSU's campus in Raleigh. It is 300 acres, and it is managed for pine and natural bottomland hardwoods. This forest is heavily used by NCSU College of Natural Resources faculty for educational purposes. Finally, we have Lake Wheeler Lab, which is also conveniently located approximately 10 minutes away from NCSU off Lake Wheeler Road. This location contains 190 dairy cattle, 80 beef cattle, 1,350 swine, and 4,500 poultry, which includes turkeys and chickens, but for the sake of simplicity, I've assumed that the poultry is made up of chickens only. This facility is also currently used by NCSU faculty for teaching, research, and extension. Next, we're going to take a look at the feedstocks and conversion processes I have chosen to use at each of the sites. To begin, at GW Hill Demonstration Forest, I have chosen to dedicate 612.5 acres to switchgrass and 612.5 acres to miscanthus. I have also chosen to use incineration as a conversion process for the switchgrass as well as for the miscanthus. At Schenck Forest, I have chosen to dedicate 50 acres to switchgrass, which will also be incinerated. Finally, at Lake Wheeler Field Lab, I have chosen to use dairy, beef, swine, and poultry waste, and the conversion process I will use is anaerobic digestion. I chose not to use Hoseley Forest as that is the farthest site from campus and the closer locations are more feasible. At GW Hill, 612.5 acres of switchgrass and 612.5 acres of miscanthus will be planted for a total of 1,225 acres. Since this is the largest site, I thought it would be best to use a large portion of it to be dedicated to bioenergy production. I also figured that since this site is used for educational purposes, this would be a great way to introduce bioenergy operation to students. This site is close to campus as well. Incineration of switchgrass and miscanthus can be used to provide electricity for NCSU's campus. Direct combustion of switchgrass and miscanthus makes energy, which converts water to steam. That steam then spins a turbine to produce electricity. At this site, 612.5 acres of switchgrass has the potential to provide 25,150,949 to 27,202,703 kilowatt hours per year of electricity, and miscanthus has the potential to provide 4,270,448 to 45,757,882 kilowatt hours per year of electricity. At Schenck Forest, 50 acres of switchgrass will be planted. Since this is a small site, I thought it would be best to use a smaller portion of it to be dedicated to bioenergy production. Also, since this site is heavily used by NCSU faculty for educational purposes, this would be a great way to introduce a bioenergy operation to students and is close to campus. Incineration of switchgrass can be used to provide some electricity for NCSU's campus. At this site, 50 acres of switchgrass has the potential to provide 2,053,139 to 2,220,629 kilowatt hours of energy per year. Finally, at the Lake Wheeler Field Lab, it holds 190 dairy cattle, 80 beef cattle, 4,500 poultry, and 1,350 swine. Since this lab is part of NCSU, I figured this would be a great place for students to learn about anaerobic digestion of livestock waste. This site is also very close to campus, which will cut transportation time. Waste from dairy cattle, beef cattle, swine, and chickens can also be used to provide electricity for NCSU's campus. Microorganisms involved in anaerobic digestion break down the waste, producing gases such as methane that can be combusted to generate electricity. At this site, anaerobic digestion of dairy cattle, beef cattle, swine, and poultry waste has the potential to provide up to 1,124,234 kilowatt hours per year of electricity. Now I'm going to discuss some advantages and disadvantages of all the feedstocks and conversion processes mentioned earlier. Some of the advantages of using switchgrass are as follows. To begin, switchgrass is a perennial plant, which means it only needs to be planted once instead of being planted every growing season like annuals. Another advantage of switchgrass is that, for the most part, it can be harvested with conventional farming equipment. Another advantage of switchgrass at this site is that it is close at all these sites is that they're close to campus, which will cut down on how long it must be transported to get to a processing facility. Shorter transportation time will also cut down on greenhouse gas emissions. Finally, switchgrass has the highest energy yield of any plant-based feedstock. Some of the disadvantages of using switchgrass are as follows. Weed control is necessary during the first planting season, which is very labor-intensive and will drive up upfront costs. Also, nitrogen fertilizers can be used to double plant yields, but adding additional nitrogen can drive up upfront costs, and it can also have negative effects on the surrounding environment. Another disadvantage of the incineration of switchgrass is that an incineration facility would need to be constructed, and that can be quite costly. A waste product of incineration is ash, and the generation of ash causes waste disposal concerns. One final disadvantage of the incineration of switchgrass is that it could be more expensive than other fuels. One study estimated that delivered switchgrass costs $46 to $123 per ton. Some of the advantages of using miscanthus are as follows. Like switchgrass, miscanthus is a perennial plant, which means it only needs to be planted once. Another advantage is that like switchgrass, it can be harvested with conventional farming equipment. Because the sites we have chosen to grow miscanthus at are so close, it cuts down on transportation time, which lowers greenhouse gas emissions. Miscanthus is also good for erosion, as this plant has a complex root system. Finally, it has the second highest energy yield of any plant-based feedstock. Some of the disadvantages are as follows. The upfront costs are high and can be about $1,000 per acre. Weed control is necessary during the first planting season, which will further drive up upfront costs. Another disadvantage is its survival during the first winter is generally poor. Nitrogen fertilizers can be used to double plant yields, but adding additional nitrogen can drive up upfront costs and can affect the surrounding environment. Another disadvantage is that a costly incineration facility would need to be constructed. A waste product of incineration is ash, which brings up waste disposal concerns. One final disadvantage of the incineration of miscanthus is that it must be stored after harvest, so these facilities would need to be built. Some advantages of utilizing livestock waste from Lake Wheeler Field Lab are as follows. Anaerobic digestion is cheaper and much more readily available than conventional energy sources such as natural gas. Using livestock waste in energy production also decreases odors and reduces the environmental impacts of animal waste by preventing the waste from running off into streams and other bodies of water. Some disadvantages of utilizing livestock waste from the Lake Wheeler Field Lab are as follows. In order to carry out this operation, an anaerobic digester must be built, and that can be very expensive up front. Another disadvantage is that the collection of manure can be difficult, tedious, labor-intensive, which could also drive up upfront costs. Anaerobic digestion of waste can also increase emissions of greenhouse gases such as methane. Finally, the conversion of livestock waste to a usable form can be costly in general. Now I will conclude my presentation. Here is a graphic displaying the median number of kilowatt hours per year for each site, feedstock, and conversion process. All of these sites combined have the potential to provide 54,452,109 kilowatt hours of electricity for NCSU's campus. Finally, in 2014, NCSU used 208,327,176 kilowatt hours of electricity. From this assessment, I have determined that the feedstocks and conversion processes that have been discussed have the potential to provide a total of 54,452,109 kilowatt hours per year for electricity for NCSU. This comes out to be a whopping 26% of the total electricity used by NCSU in 2014. By implementing renewable bioenergy sources, NCSU can lower its electric bill, decrease its dependence on fossil fuels, and establish a sustainable way to meet campus energy needs. Thank you for listening.